We are still on algebraic expressions, and in this video we're going to be learning what we call factorization by grouping. So I have a couple of examples that will help us to understand what factorization by grouping is all about. So let us look at this example. Let's start with this question here. Factorize the following. So on part A we have a squared plus 2ab minus 7ab minus 14b squared. And on part B we have 3ac plus 4bd plus 3ad plus 4bc. So we just want to learn how we can perform what we call factorization by grouping. Maybe the question here would be, under what circumstances can we apply this method of factorization by grouping? You're going to find that in many algebraic expressions that you'll be given in your examination for you to factorize, some of them won't be having a common factor that stretches from the first term to the last term, like we have here on a squared plus 2ab minus 7ab minus 14b squared. There is no common factor for all these terms. So rather in this case, what we can do is we can group the terms, because if you look here, these first two terms have a common factor, and these two terms again also have a common factor. So what we do is we group the terms like that, and for these two terms, a squared plus 2ab, we can look for the common factor. In this case it's a. So I factor out a and I divide a into a squared, and what I get right there is a. I also divide a into 2ab, and what I will be getting there is 2b. Again I group the other two terms right here, and put a minus sign, and the common factor here I'm gonna take minus 7b is the common factor, and I divide minus 7b into minus 7ab. So what I'll get is positive a. Again I divide minus 7b into minus 14b squared. Remember, minus and a minus divided will give us a positive. So here I'll be getting positive 2b. Alright, so I'm going in the right direction, because you can see from this expression that we now have that we also have these two terms which have a common factor of a plus 2b. So again what we do is we factor out a plus 2b, which is a common factor, right, and we divide a plus 2b into this expression right here. And if we do that, a plus 2b we cancel out with a plus 2b, and we'll be left with a. So we factor out we get a from there. Again we divide a plus 2b into this whole expression right here, and a plus 2b will cancel out with a plus 2b, we get minus 7b. So we have minus 7b right there, and this becomes the solution to our problem, a plus 2b bracket a minus 7b. So that's simply how you can perform factorization by grouping. We just want to try that again on part B. On part B we have 3ac plus 4bd plus 3ad plus 4bc. Now if we were to group the terms like we did on part A, then we'll be doing it like this. But there's a bit of a challenge here, because if you look at these two terms, they have no common factor, and so do these two other terms, which means that here what we have to do first is to regroup the terms, because I'm seeing here that 3ac and this 3ad are terms that have a common factor among them. So what I'm gonna do here is I'm gonna group them like that. So I take my 3ac and plus 3ad, and I also take 4bd and 4bc, such that here I can now group the terms in pairs like this. Alright, so let's start with this 2. We have 3ac plus 3AD. The highest common factor for 3AC and 3AD in this case is actually 3A. So I factor out 3A and I divide 3A into 3AC. What do I get? I get C. And 3A again into 3AD, we get D, right? We move on, we also factorize the other terms right here, and the highest common factor right here will come out as 4B. I factor out 4B and I divide 4B into 4BD. What I get is D, and 4B into 4BC, what I get is C. Alright, and from this stage I hope you can notice here that we also have a common factor in C plus D, because C plus D is the same as D plus C. It's the same thing, right? So we can factor out C plus D, and next we divide C plus D into this whole expression. What I get here is 3A, so that will be 3A. Again I divide C plus D into this other expression, and what I get is 4B, and that will be the solution to part B. So this is how we perform factorization by grouping. Now I know you'd want to attempt your own problem by yourself, so I'm going to give you this example in order for you to work out. Right, so I want you to factorize 2x cubed plus 6x squared minus 8x minus 24 completely. I'm going to be giving you just 2 minutes to do that, so I want you to pause the video starting from now. Alright, so let's go on to the solution. Alright, so we have our expression 2x cubed plus 6x squared minus 8x minus 24. I group the terms like this because they have a common factor. Alright, so I start with this 2, the highest common factor right here. I'm saying that it's 2x squared. But see, before I do that, you can also see that there is a common factor that is stretching to all these terms, and 2 is that common factor, right? So what I've just done here is I factored out 2 first, so that I can start factoring out the common factor, which is the common factor, highest common factor for these 4 terms. So if we factor out 2, then we'll be dividing 2 into each of these terms, right? So that's what I want to do first, and that is the first thing that you need to look into when you perform factorization. First, check out if there is a common factor for all the terms. In this case, there is. So that means that we'll be having, if we divide each term by 2, we get x cubed plus 3x squared minus 4x minus 12. So that is the first thing here, because there is a common factor for all the terms, and that is 2. After that, we can continue factorizing. Remember, we want to factorize it completely, right? So then I can group my terms, so these 2 terms and these 2 terms. Alright, so I'll have my 2 here, and I open up a square bracket just like that. And for these 2, the first 2 terms right here, the highest common factor is actually x squared. I factor out x squared and I divide x squared into x cubed, and what do I get? I get x. I also divide x squared into 3x squared and I get 3, right? Again, I go on to these 2 terms and I factor out minus 4, and if I divide minus 4 into minus 4x, I get positive x. Again, I divide minus 4 into minus 12, I get positive 3, right? And I continue to work on this expression. Let's just have a little bit of space. So I have my 2 right here, and open up my bracket, and I have a common factor now in x plus 3 for the two terms. So I factor out again x plus 3 and divide x plus 3 into this whole expression. What I get is x squared, and also dividing it into this whole expression, I get minus 4. So this is the minus 4 that you're seeing right here. So this is what we get. We have 2 of x plus 3 of x squared minus 4, right? So you may think that we are through factorizing, but actually we're not, because this algebraic expression here, quadratic, can also be factorized using what we call the difference of two squares. So we call that the difference of two squares. So in this case, if we have our 2 of x plus 3, then for this part, using the difference of two squares, according to the principle of the difference of two squares, if you have two squares in subtraction, a squared minus b squared, then this will be equal to, when factorized, gives us a plus b of a minus b. So that's what we have here. We've got two squares. If we have x squared minus 4 is the same as x squared minus 2 squared. So for the difference of two squares principle, it becomes x plus 2 x minus 2, and that's simply what we get, x plus 2 x minus 2, and that becomes the solution to our problem right here. Alright, so that's simply how we perform factorization by grouping. I'm going to be giving you more examples for your practice. So thank you for watching this video.